Hi everyone, so today we're going to be looking at a simple stoichiometry problem, and I'm going to walk you through the steps of how to solve one. So let's take a look at the problem. We have 34.5 grams of glucose react in the combustion reaction below. How many grams of carbon dioxide are produced? So let's first separate our knowns and our unknown. So first we know the grams of glucose as this was given to us in the problem, and it's 34.5 grams. We also know the molar mass of glucose, and we can figure that out by looking at our periodic table and looking at the molar mass for carbon, hydrogen, and oxygen, and multiplying each molar mass by the amount of molecules that there is. So for carbon, we would take the molar mass and multiply it by 6 and add it to the molar mass of hydrogen times 12 and add that to the molar mass of oxygen times 6. And we also know the molar mass of carbon dioxide, and we would figure that out the same way. We would take the molar mass of carbon and add it to 2 times the molar mass of oxygen. And finally, we know the molar ratio of carbon dioxide to glucose, which is 6:1, and we can determine that by looking at the chemical formula. We see here that there are 6 moles of carbon dioxide to every 1 mole of glucose. So the only thing we don't know is the grams of carbon dioxide. And we are going to set up that problem here. So first we need to take our known and eventually transform it into our unknown. So for the first step, we're going to take our given quantity of glucose and we're going to divide it by the molar mass that we determined before of glucose in order to go from grams of glucose to moles of glucose. So we would divide 34.5 grams by 180.2 grams. Again, we're canceling out the grams to go to moles. So we end up with 0.19145 moles of glucose. And we're going to leave more significant figures than what we need, which was given in the problem, so that we don't create rounding errors. So we will round our significant figures at the end of the problem. So now that we have moles of glucose, we can use the molar ratio determined in the previous slide to go from moles of glucose to moles of carbon dioxide. And to do that, we need to make sure we have moles of glucose in the bottom portion of the fraction so that they can cancel out and we end up with moles of CO2. So we will multiply 0.19145 times 6 to get 1.1487 moles of carbon dioxide. Again, I'm leaving more significant figures than what we need just to not create rounding errors. So now that we have moles of carbon dioxide, we can change that easily to grams of carbon dioxide by using the molar mass that we determined in the previous slide, which is 44.01 grams. Again, we need to have moles of carbon dioxide in the denominator here so that they can cancel out and we're left with grams of carbon dioxide. So when we multiply 1.148 moles times 44.01 grams, we end up with 50.552 grams of carbon dioxide. And in order to get this value into the correct significant digits, we know that we have 3 significant digits that were given to us in the problem. So our answer should be recorded to 3 significant digits. So in doing that, we round our final answer to 50.6 grams of carbon dioxide.